Okay, good evening everybody. So tonight is our last class, right? Okay. So how is your feeling? So at the end of this class, did you like this class? Huh? Overall, did you like this class? Did you learn something new? Okay. I wish I could teach more in this class because there are a lot of interesting things I have to shorten or I have to skip because of time limitation. Okay, let us start with just review for tonight. Okay, this class is open. You can sleep or you can. Where are the sleepy people? Okay, you can sleep or you can watch any movie or video or whatever you can. You want to do. Okay, you can do. It's open for now. Or if you like, you can leave early. But if you miss something, I'm not responsible. Yes. Yes, it will be assignment 8A. Only A. Later I will see. That is for lab class. I will see this theory class. Okay. So this is a two-dimensional array. So as we know that a two-dimensional array, my array name here is grid. Okay. As we know that a two-dimensional array is an array of arrays. Here I have three arrays. This is my first array. Everybody see on the back? Okay, and this is my second array, and this is my third array. So this is actually this declaration and assignment is together, but there is an alternative way that I could assign value like this way: grid 0 0 0 0 equal to 5, like this way. Get 0 1 equal to 7, get 0 2 equal to 4, this way. But this is the shortest way. But if I display this array in a two-dimensional or matrix form, then this will be more likely an array of like 5 7 4, and then in the next line it will be 5 7 7, and in the next line it will be 3 1 0. So values will be like this, right? If I display this in, okay, it will be like this. So this is element 0 0, grid 0 0, this is 0 1, this is 0 2, this is 1 0 1 1 1 2, this is 2 0 2 1, and this is 2 2, right? So let us do something. For instance, we can do a lot of things, but in order to operate a two-dimensional array, okay, so we need to use two loops. Here we have two for loops. This is called outer for loop and this is called inner for loop. The outer for loop is used for accessing by row. I have 3 rows here, right? So 5 7 and 4, this is the first row, this is second row, and this is third row. So this is why I need to do 3 iterations. I equal to 0 to 1 to 2. So how can I do that? So I equal to 0 to I less or equal to grid length minus 1. So if you use equal sign over here, then you must need to use minus 1. So if you want to, if you do not want to use minus 1, and then you have to use less than. Okay, otherwise it will go out of index. Okay, then so it will, this outer for loop will ensure that this inner for loop, inner content will be executed 3 times. Okay, for the first times while I equal to 0, it will be j equal to 0 to j is less than grid dot length. Actually grid dot length here is the, and for a 2-dimensional array, the length is considered as the highest number of either row or column. So highest number of row and column both are over here 2, so 3, number of columns and number of rows, so 3, so length will come as 3. So while I equal to 0, then it will come up j equal to 0, 1 and 2. Then again while I equal to 1, then j will be 0, 1 and 2. Then again when I equal to 2, j will be 0, 1 and 2. Then what is doing here, I am just checking whether I have my intended, my specific number, my target number available in this list or not. Okay, so my targeted number is 7 over here, I thought. It's hard-coded number. So I'm checking if grid ij equal number, then I'm doing 2 things. I am okay. So I'm making my flag equal to 0. I created a flag, boolean flag is equal to false, and then I'm making it true, and then I'm counting how many times this number is available here. Okay, so if this number is found, then it will increment the count. Initially count is 0. So for this case, I can, if I run this program, then I will see the number 7 is found 3 times. 7 is found 3 times, 1, 2 and 3. So if I search for maybe number 11, it should not be found. Okay, the 11 is not found. So this is a simple way that I can do in operation on a 2-dimensional array, and then I can do something more. For instance, here I can check whether my number is an even number or odd number. I can check whether my number is an even and small, or odd or small. Okay, so I'm just giving a startup for your test practice for the in one of your tests there is a question to check whether to find the smallest even number or smallest odd number for a 2-dimensional array. Okay, practice this for that test. Okay, anyone has any question? Then you need to change here. You need to make some update with here. So if you are not allowed to use a hard-coded number, so definitely you have to use like another method. You need to use a combination of another method. Find the minimum or maximum. Minimum and find the even, both together. So in that case, the if condition will be a little bit complicated. 2 conditions will be over here. Okay, and we may need to want another temporary variable to put the lowest, to get the lowest number. So practice this. You may be asked to find the greatest even number or greatest odd number or lowest even number or lowest odd number. Once you understand one thing, you can you should be able to understand another thing. Okay, yes.
I've seen examples where when looping through a 2D array, for the second loop, the column, the valuable variable j would have to be less than grid of it would set brackets and then the loop
Here.
Like after grid, you would put a set of brackets and then I in those brackets.
So this is Java version. In C# version, I'm not sure what you are asking. In C# version, it has like this: I, comma j.
No, that's not my question.
Okay.
So the for loop.
Yes.
The second for loop.
Yes.
I've seen it where to loop through that, you would put j less than grid and then a set of brackets and then I in those brackets.
Okay. So then like this. There may be an alternative version to do this, like you are saying this. You're saying this? Huh? Dot length? So yeah, if you say that it will go the length of this row. This one? It should work.
How would you count the length of the
Here?
Yes, if you want to make a counter that would run through the amount of
So it is what is coming here? So in array, if I put length, then what is here? It will count that how many numbers of rows or columns maximum. I mentioned that, right? For here, you are explicitly counting the so this for I equal to 0, you are counting this will be 3. For I equal to 2, this will be 3. For I equal to 3, this will be 3. This will work too. Good question. Okay. Thank you. There are different versions. Let us understand the logic. If you understand the logic, then it will work. Okay. Thank you for your question. But in order to find the maximum even number or minimum even number, so you need to add one more variable over here, temporary variable, and then one more condition over here with and if grid I, for instance, like if you want to grid I modulo 2 equal to 0, this will be for even. This will start for even. So okay. So like this, you have to add one more variable, temporary variable, to find the lowest or highest. To solve that one, okay? Replace that one, okay? That is your call. You need to learn that one. That was in your previous test as well. Okay, so then you need to go through sorting algorithm, one of the sorting algorithm, okay? And you will be given not to write algorithm or program, you will be given some data, and likely for your last test you will be asked to write the values after each iteration. Okay, let us do with a bubble sort. So can anyone please tell me a number, a bubble sort? Just I'm giving you some. So as we know that, as we discussed in last class, a bubble sort algorithm. So that's how do you implement a bubble sort algorithm? For instance, someone please help me to give me a number. Tell me a number. If my array ARR, my array equal to like this. Tell me a set of numbers, please.
10.
10. Sorry. 10.
4.
4.
8.
8.
2.
2.
7.
7. Okay, let's try with this one. Okay. So the bubble sort, the concept is that it will create bubble. So this is a bubble, right? So like this is a bubble, and for instance this is a bubble, but for easiness, let us consider we don't have this part. So we have only the circumference. So it will create a bubble or ring between the first two numbers, okay? And then it will compare whether we want to ascending or descending order. Okay, the ascending order, smaller to high. Okay, then it compare whether this number is greater than, is less than, this number is less than this number. Okay, if it is yes, then it will solve. So yes, then it will solve. Then 4 will come here and 10 will come here. Okay, and then it will bring 8 down here. Then it will make the bubble larger. And this time it will compare this 4 and this 8. Not inside the bubble, not outside the bubble, only in the edges of the bubble. So then 4 is always less than 8, so we don't need to make any swapping. So then it will bring down 2 and will make the bubble larger. This time it will compare 4 and 2, not 8 or 10, okay? So this 8 or 10 will be as is, and then 2 and 4 will be compared, so this will be replaced. 2 will come here and 4 will come here, right? And then this time 7 will come down, and then your bubble will be way larger, and then 2 and 7 will be compared. Since these are already sorted, we don't need to do this. So this will be after at the end of first iteration 1. Okay, so after first iteration, at least one number will be sorted, and at this point, actually, your next array will be this one. This will be considered because this number is already sorted with this array. Okay, so the 2 is already sorted. I don't need to do anything, already 2. For 2, then 8, 10 and 8 will be compared, and then this will be swapped. So 8 will come here and 10 will come here, and this time 4 will come down, and then 8 and 4 will be compared. Then 4 is less than 8, so 4 will come here and 8 will come here, and 10 will be as is. Okay, 10 is as is, and then now I will have 7 down, right? So this time I will have another larger bubble that will have 4 and 7. Okay, so now we will compare 4 and 7, not inner 2s. Okay, so then this time 2 as is, and then 4 also is less than 7, so 4 is already in place. 10, 8 and 7. So at the end of second iteration, I will have at least 2 elements sorted, right? Okay, so this is at the end of iteration 2. Okay, so now in the third iteration, we need to check already the sub-array of this part. Okay, so in your test 1, you are asked to write only the last situation, this line. Okay, so you can show this inner calculation or not. Okay, but these are the compulsory. This is line we wanted to show. Okay, last time we gave some forgiveness that some considered that it's okay. Whatever you wrote, if it's sorted, then fine. But this time, you have to write down exactly as is. Okay. So do some practice. Anyone has any question about this? Do I need to go through all of this remaining part? We'll know that, right? I think you should be able. So like this. So what is the complexity of bubble sort algorithm? So bubble sort algorithm is complexity n squared, because almost all of the sorting algorithms have complexity. Almost all have complexity n squared. Because when you are in the first iteration, you need to do n minus 1 either swapping or testing. And the second iteration, you need to do n minus 2 testing. So ultimately n minus 1 plus n minus 2 plus n minus 3 plus dot dot up to 1, if you add up, then your summation will be big O of n squared time. Okay, so what is another sorting algorithm in a syllabus? Selection sort? Okay. Selection or insertion? Insertion maybe? Yeah. Maybe insertion. So you need to know about that one as well. Okay. I don't know, you don't know which sorting algorithm you will get in your test. Okay, now I want to go quickly because time is short. So you don't sleep today? You don't sleep today? Tonight? Okay. So then we discussed binary search tree, right? What are the characteristics of a binary search tree? Binary search tree is a non-linear data type. Okay. So a tree there are two non-linear data types, graphs and tree. You will know about graph in your data structure class. So for tree, there are some characteristics that will be a single parent or two or more children. Okay, left child, right child. These are the characteristics of tree. Then we went through the binary search tree. The binary search tree, we discussed the characteristics. Okay, the example of binary search tree. This is an example of a binary search tree. Okay. So these are the leaf 2 and 7. These are the leaf, and then in the middle elements, these are we call node. It's a left node or child, left child and right child. Okay, and this is the top one is the parent child. In a binary search tree, all elements in the left child are less than the parent, and all elements on the right side are greater than the parent element. Okay, this is the main thing. So I remember this way how to check whether it is a binary search tree or not. This way to go start from the end. 2, 4, 6. If you find an ascending order number, then it is good. 2, 4, 6. Okay, then 9, 10, 12. Then go 4, 8, 10. Okay, then 8, 15, 25, and then 7, 20, 24, 28, 30, 36, 20, 25, 30. If you go, when you read aloud, if you go smoothly, then it's okay. And if you get stuck, if you got disorder, then it's not a binary search tree. Okay. Then we discuss, okay, how to insert elements in a binary search tree, and then we maybe we went through the traversing, right? There are three kinds of traversing: pre-order, in-order, and post-order. Okay, so this is an example. Okay, so let us go through this. So in-order means, as we discussed in our last class, I showed you program. So just put the print method, print line between left node and right node. Okay. So in order, print means put the parent in, means in between two children, left child and right child. Here in order means my child, look at here for the first one, 4 is my parent, right, for 2 and 6. So when you go in order, the letter the 2, 4, 6, and then come to this way. Two, 4, 6, then it will come. So when it come to 2, 4, 6, this branch will be ended. Then you will go its parent. 8 is its parent. 8 is the parent of this branch. So then it will come 8. Okay. Then after 8, when you come 8, you will come all the way end of the list. Okay, then 9, 10, and 12. Then when you come 9, 10, and 12, then you are done this part. Then you have done all of this part from here, this side. Then when it to go is the parent of this part is 15. Then you need to go to 15. Then when you do 15, then we need to come back all the way end to here. 17, 20, 24. Then when you go 7, 20, 24, then you have to go to its parent. Who is its parent? 25. Okay, then when you do 25, display 25, then you need to come to this branch and all the way into this branch. Is the left element, left leaf. A node that has no child is called a leaf, right? So 28, 30, and 36. Okay, so this is the in-order traversal, and you need to know in-order, pre-order, and post-order. Okay, so this slide is a good example to understand in-order, pre-order, and post-order. Okay, and although these slides do not have complete program, but I showed you complete program. In my GitHub account, I have posted a complete program. Anyone has any question about BST? Okay. Then also in your class, we went through stack, QE, and linked list, right? Okay, for the stack, do two operations, push and pop, right? You have to ask, you may be asked to write code for the push or pop. Okay, step for QE, NQ, or DQE. Okay, and then we also discuss about singly linked list, right? We discuss about append, prepend, and okay, last time in the last test you had find by ID. So this time you may be asked to write the code for remove by ID. Okay, what is your question?
Are we just kind of going over everything right now, or are we going over what's specifically on the test?
I'm giving you. These are the things I am discussing. Okay, so who are talent, then you can find some. Listen to me carefully, then you will find something useful. Okay. I don't know yet that what will be your exact question. Actually, I will not be able to know until exam time. So, okay, then I discussed something more maybe. Okay, for the test 3, you have a question to write the display, okay, the number. So if you write a recursive method, right, you have to write a recursive method that will display your number in descending order or ascending order. If you know one thing, then you should be able to do another thing. For instance, if my method name is REC is the method name and it takes integer n, then what I want to do, I want to display from the numbers from 1, 2, 3, n. Okay, I can display this, or I can do whatever you want. I can do display square of this number. 1 times 1 equal to 1, 2 times 2 equal to 4, 3 times 3 equal to 9, n times n equal to n square. Okay, whatever you want, or I need to do square root. Okay, so whatever you need. Okay, so that I use static over here, static modifier, so that I don't need to create an object. So static, I put integer. So what is my number? I say, for instance, actually I can do this. Okay, static integer, my recursive method is over here. So for a recursive method, I must need a base. Okay, the base should come top. Some people they give base later, but it's not a good way, good code. Okay, so base code should come here if n is your base, n equal to 0, or you can say less equal to 0. So if your n less or equal to 0, then what it will return? It will return 0, right? 0 square equal to 0 or number 0 equal to 0, right? Otherwise, it will return, it will do else, what it will do? It will call the recursive method, right? So it will call the recursive method REC with argument n minus 1. And then here is the magic. If you want to display in ascending order, okay, then you have to give the print, okay, for instance, print n times n plus some space, for instance, after you call recursion. That will make an ascending order. Okay, but if you give this line, that one line at the before you call the recursion, it will do a descending order. Run this program and make some changes, this change, and run it, then you will understand. The reason, because here in this program you see that I am printing here n, so what it will do? It will display in descending order, because whatever your value, it will display that first, after it will call the recursion. But just if you write this line, the same program, if you give, so let me show you the output. So it is going descending order, right? So if I, instead of n, if I type n times 10, for instance, it should show me squared, cube, right? Okay, for 10, I'm calling by 10. So 10 cube, then 9 cube, then 8 cube, then 1 cube. Okay, so if I want to just this line, if I give this line here after the recursion, what it will do? It will do in ascending order. Okay, sorry, I did a mistake. What is that? Unchangeable code? What is this? Oh, okay, that's good. Yeah, I cannot do below return. So let me say my ascending order. So in order to do ascending, actually I need a void return type instead of return type integer. So what you do, okay, let me change this. So instead of making return type integer, I can make it void. Then if I make it void, just I need to just return. Okay, then I don't need to return statement here. Okay, and it should work. Okay, at this time, if I bring this line here and down, then it should work. So if I know the logic, I can do square or square root or okay, the last thing I want to discuss about abstraction. Okay, so let us consider I have an abstract class name animal. Okay, by default, all classes extends object class, right, as its parent. So if I write extend object or do not write extend object, same thing. Okay, it doesn't matter. Okay, so for this one, if I want to add one abstract method, so then in order to add one abstract method, so I need to add abstract keyword. Okay, then my method signature. This one is the header line of method. Okay, so if I declare a method as an abstract method, I cannot make any object of this class. That means my class needs to be an abstract class. So you see that as soon as I made my method abstract, then my class needs to be abstract. So an abstract class contains at least one abstract method and as many number of non-abstract method it can contain. The difference between an abstract method and a non-abstract method is that an abstract method cannot have a body implementation, cannot have an implementation. It says this is ended here, but this is non-abstract method, it may have a body as long as needed. Okay, then if I want to create an object of this type, animal type, I need to create another concrete class that will extend this animal class as well as this will implement move method. For instance, this is my human class. If I want to extend the animal class, then I must need to implement move method. Actually, I can implement move method over here. So whatever I need to do something. Even if I do not do anything, I need to keep a blank body. But that is must actually. Okay. And in this concrete class, human class, it is compulsory that I will implement my abstract method, and I may have other methods as well as. But if I want to do something, so this is the default implementation of non-abstract method in the parent class. But if I want to do something else, then I need to override this one, the non-abstract method. Okay, so this is the human class. So once I have my animal class, then I can animal abstract class, then I can extend that class in any number of subclasses. That means I can create other classes. For instance, I have bird class, I had human class, I can create bird class, I can create cow class, I can create goat class, I can create sheep class, as many number of classes as I need I can create, but the condition is that I need to implement my move method. In this case, overriding is optional. You can do override over here, or you can do here. Actually, let me bring my back. But actually this is not overriding. Okay, so okay, so this is the main part that we discussed in a previous class. So right, one is, so I have, how many classes I do have here? I have my animal class, then I have my human class, and I have my bird class, right? So then if I say, for instance, let me say, if I want to create, if I say animal A, okay, this line is fine. Okay, animal A, right? I just created a reference of animal type. Now if I want to assign A equal to, can I do new animal? Can I do A equal to new animal? Can I do it? What is the reason? Yes, no, I cannot do it. What is the reason? Yes, animal is an abstract class. It cannot create an object, right? So I have to create an object of a concrete class. It's subclass. So my animal has two subclasses. One is bird, another is human. Okay. So then I can say animal equal to new bird. Okay. Then it is okay. Now if I do a dot, then it will show me the methods that are available in the animal class, also in the object class, that is the greatest parent, as well as it should show me, okay, what is its own method. Okay. Okay, so then I can show you that something. If I say a dot, you see that a dot animal is moved, right? So then, if I say a dot animal, and then it will show me the activity of moving activity of my bird class. So whatever I have in my bird class defined in my bird class, whatever I have for my move, that it says bird can talk, can walk, fly and run. Okay. Then if I run this method, so let us go through only this part. Okay, not before this. Where is that? Let us go through the example of before this line. Okay, I want to see the example before this line. Okay, so it is showing me birds can walk, fly and run, whatever I have in birds class. But if I would say I would create an animal instance of human type instead of bird, then this same move method would show me some different activity. It says human cannot fly but can walk and run. These are the text, or these are the activity I have in my human class. So although you see that here we are learning or discussing the main concept with some examples, pretty simple example, right? A demo example. So in your actual programming, okay, in your job or actual field, instead of doing something here, just instead of displaying some print line, you will do something else. So when you go for job interview, they will not ask you to do something else. They will ask you like this way, that whether you understand the basic concept or not. So if you understand the basic concept, then instead of implementing the move method by writing one line, if you understand the basic concept, then you can implement this method whatever needed. Okay, so this is the concept of polymorphism. Okay, this is the concept of polymorphism, runtime polymorphism. Okay, this is good concept of polymorphism. If you understand this thing until this, then you're good to go for interview. Okay, so now let us do something else. Okay, so let us do an experiment. Do we have interface? Okay, so if I want to change this animal class into an interface, then what changes I need to do? Can anyone please tell me? I want to change this abstract class is a virtual class. So I want to make let me do something else. A new package. What do I want to call it? Abstract class to interface. I want to copy and paste this entire code. Yeah. Okay, so what I want to do, I want to convert this animal class to an interface. So all interfaces are by default abstract. An interface is 100% abstract. So then you don't need to tell abstract interface. Okay. So just interface is fine, but it is not showing me an error. But it is an interface is 100% abstract. So you cannot have any body of an abstract anything in an interface. So I cannot have this body. I have to delete this, as well as I have to end of this method by putting a semicolon. Okay. So okay, one changes I have done. What other changes I need to do? I have error here, right? So now this time my animal is not a class, it is an interface. So I need to use implements keyword. Okay. Then this error is gone. Then I have another error here. What is this one? So again, animal is not an abstract class, so interface, so I need to put it here, implement. Okay, that's gone. Then this program will do the same output. Okay. And last time we discussed how and why do we need to override the toString method. Remember anybody? Yes, in order to display your object in your expected format. Okay, and okay, for instance, if I have an interface vehicle over here, right? I have a class max speed, max capacity. Let me add two more string, integer string make, and string model. Okay, so I added two more additional attributes in my car class. So then, okay, I'm not overriding the toString method, but you should know this, how to override toString method. Okay, so then let me put some value for okay, for what is my okay, so here my car constructor is here, right? So string car info, I need also string let me move what is called car info. Okay, let us add this string make and then string model. Okay, so then when I create an object of this class, I need to create car info and also make and model, right? For instance, make, I say Toyota. Here is make is Toyota. Okay, and model is Camry. Okay, one is done, and another is here. For instance, I need to give here make is Maruti, and I need to go this way as a string, and I need to model Swift. Okay, so now if I want to create another method that will check whether these two car objects are equal. Okay, so for instance, I want to add one more method over here. For instance, public void, what is that called, is equal car or is same car. Okay, actually it's not is void, actually I can say boolean. I can say boolean. Okay, return, I need to return something. What I need to return? So I need, for instance, is same car. I am putting car object, car C. For instance, I am to return C dot make dot equals, right? Equals actually I need car C, I need two object, C1 and car C2. Okay, I need to, if I want to compare two cars whether they are same object or not, then C1 dot make equals C2 dot make. Okay, and as we know that in order to be a same object, all attributes need to be same. Okay, what are the attributes I have here in my car? Okay, so all attributes I need to check. So I need to check make, model, vehicle info, vehicle speed, and then this. Actually, what I need to check here, I need to check not all these. Actually, I need to must check what are in I do have in my constructor. So in my constructor, I have car info, I have make, and I have model. So then, in order to implement the equals method, okay, so then I need to do c1 dot car info like this. c1 dot not make car c1 dot car info what is the vehicle info, right? Okay, it has vehicle info. c1 dot vehicle info, okay, equals c2 dot vehicles info, okay, and c1 dot make equal to c2 dot make, and c1 dot model equals c1 models equal c2 dot model. If all three conditions I need to give one here, I need to give another here, I need to give one more here. Okay. Okay, so here I have like either is same car or is equal. For instance, is equal or is whatever I say, is equal or is same car. Okay, is same car or is equal car. I have this my implementation of equal method actually. Okay, now if I push this call is same car method by using the two car object, my car 1 and my car 2, then what will be my output? Okay, actually I need why it's not showing here, I need a static. Okay, vehicle how is that come? Car, vehicle. Oh, it is an interface. What is the method is undefined in the vehicle is same car, car. I have defined it here. I don't know, something error that it is not showing me. Is same car is this method? What is my method name? Is Live static. Okay, let me copy that part. Car1, okay. C1 and C2. I'm just showing some error. Okay, if I run this, okay, if I use sys out, okay. Boolean b equal to okay, I don't know, there is some error here, but this is the way to okay. What else I need to cover? And then we discussed parallel processing, like threads, right? Threads and multi-threading and parallel processing. So in the feature, in the slides, there are advantages and disadvantages of parallel processing. Okay, go through the advantages and disadvantages of parallel processing. That's it, and mainly, and also go push, pop, NQ, DQ, okay, and insertion, and then for single linked list, last time we discussed append, and then search, and also study for remove. Okay, anyone has any question? Okay, good luck. And the test is here on next Tuesday at 6. So if you come at 6:30, you will be late. Tuesday.